Welcome to Chapter 7, Paired T-Test and Paired Wilcoxon Test. This video shows how to process the paired T-test and the paired Wilcoxon test. You can watch the entire video or use the time slider to navigate directly to any time point. The paired T-test is similar to the T-test. But whereas the T-test involves a two-group design to determine if one group performed differently from the other, the paired T-test involves a one-group design and determines if those in that one group performed differently at two different time points. In this example, a coach works individually with each student in an archery class. Each student is instructed to shoot 10 arrows at the target while the coach unobtrusively observes and takes notes. The coach records the total score for the first round, 10 points for the center ring, 1 point for the outermost ring, and 0 points if the arrow misses the target. This is the pre-test score. Next, the coach provides each student with individualized constructive feedback based on the observations made during round 1. Finally, the student reclaims the arrows and shoots a second round of 10 arrows. The coach records that score as the post-test score. After coaching each student individually, we find that the mean pre-test score is 45.22 and the mean post-test score is 49.56. The paired T-test will compare the pre-test score to the post-test score and compute the p-value. If the p-value is less than or equal to 0.05, we would conclude that there is a statistically significant difference between the pre-test score and the post-test score. If the p-value is greater than 0.05, we would conclude that there is no statistically significant difference between the pre-test score and the post-test score. The scores were about the same at both time points. The paired T-test has one pre-test criterion: normality of differences between each pre-test score and the corresponding post-test score. If this criterion is satisfied, then run the paired T-test. Otherwise, run the paired Wilcoxon test. This example uses the dataset ch07_demo. On the R syntax guide, go to page 8. In Packages, check MV Norm Test and Psych. To check for normality of differences, copy this line of code to the console window. Change the file name to ch07demo here and here. Then change pre-test to pre-coaching and change post-test to post-coaching. And press Enter. Here we see that the p-value is 0.2614. The p-value is greater than 0.05, indicating that the differences between the pre-test score and the corresponding post-test score for each student is normally distributed. Hence, this criterion is satisfied. We'll proceed with the paired T-test. Copy this line of code to the console window and change file name to ch07demo and press Enter. Here we see that the pre-coaching mean is 45.22 and the post-coaching mean is 49.56. Now copy this line of code to the console window. Change file name to ch07demo here and here. Then change pre-test to pre-coaching and change post-test to post-coaching, and press Enter. The p-value is less than 0.05, indicating that there is a statistically significant difference between the pre-coaching score and the post-coaching score. To calculate the delta percent, copy this line of code to the console window and change pre-test mean to 45.22 here and here. Then change the post-test mean to 49.56 and press Enter. This indicates that there was a 9.6% increase from the pre-coaching average to the post-coaching average. If the pretest criterion was not satisfied, then the paired Wilcoxon test would be the appropriate statistic to run. Copy this line of code to the console window. Change file name to ch07demo here and here. Then change pre-test to pre-coaching and change post-test to post-coaching and press Enter. Document the results using this p-value. This concludes this video.